Hi, Erko here from ScriptRunner Connect, and today I am attempting to build a new integration using AI assistance exclusively, also known as vibe coding. For those who are not familiar with ScriptRunner Connect, then it's a code-first integration platform, which is rather unique because most of our competitors are usually no-code. But when it comes to the AI assistants, this is a huge advantage because we can take latest and greatest off-the-shelf AI tooling and use it with ScriptRunner Connect. So I am going to use Cursor to do my stuff here. And I'm not going to talk too much about the setup because I'm following our recommended setup. So the only difference here is that instead of VS Code, I am using Cursor, which is a fork of VS Code. So anything that works in VS Code will work the same way in Cursor. You can get this documentation when you go to our documentation page, and under external coding there is a section about recommended setup and worth also checking how to work with AI agents. So let's now talk about the integration I want to build. In ScriptRunner Connect, you can receive email notifications when your scripts blow up, when they fail. However, we currently don't have native integration with Slack. Today I will try to build an integration so when something blows up, I will receive a Slack message, including also the reason why the script blew up. To do that, I can use the public API of ScriptRunner Connect. We currently don't have much here, but we do have API endpoints for reading the logs. And in my case, that's everything I will need. To read our API docs, you can go to this URL. And if you want, you can also download the OpenAPI specification, which I will be using later on. And now back to the workspace. I have it set up a little bit already. I have a script that I will start running on a schedule. When it runs, it finds out the latest logs. It will then analyze those logs, and the ones that failed, it will send a message to a Slack channel. I have then set up already an API connection here for Slack, so I can communicate with it. And since we don't currently have our own connector nor a managed API for our own API, I'm going to use a generic connector, which I already have set up. And then I have a scheduled trigger here, which is set to trigger on every 15 minutes. But currently I have it disabled because when I'm developing it, I can run the script manually without having to wait it to run for me. And I have set up a couple of parameters also that I will be needing to complete the integration. So I already have figured out what's my team ID and have it set here. And then we have a workspace ID here, which is used to find the logs for. And I'm noticing that I actually have a different ID because I would like to start testing this integration against the same workspace. Let's quickly fix this. Then we have the environment name, which you can define which environment you would like to receive the logs from. Currently we are going to use the default environment. Then we'll have a Slack channel where we want to send the script notifications into. And finally, there is a concurrency, and I want to make this integration run concurrently to some extent, and the part that I want to run concurrently is the one that fetches all the logs from the system and analyzes which one of them needs to be notified. The reason for that is that the script can run up to 15 minutes, but if there are too many logs, let's say 1000 and more, it may take too long. So if I will parallelize it, it will run those jobs in parallel. but I don't want to run them in unlimited parallelism because I will then certainly hit rate limits. So I have configured here the number of jobs I want to run in parallel. And that's pretty much what we have done with our workspace so far. The next thing to do is to set up the remote workspace access so I can start developing the code for it in Cursor. And to do that we can go here and click on remote workspace. First we have to enable the SFTP server, and then we have to generate credentials for us. And here is a file that we then have to use in Cursor to set it up on the Cursor side. Like mentioned, I already have the necessary extension installed in Cursor, which you can follow from our documentation. So the first thing I will need to do is run the sftp config command. This will create a new default configuration. I will now copy over the one that is provided from ScriptRunner Connect, put it here. And the only thing that I have to swap out is to provide a private key. I already have my private key. However, if you set up the remote workspace for the first time, then you will get to download your private key. But any subsequent setups will reuse your existing private key. So in my case, I simply have to use the one that I already have downloaded. I will quickly copy in the path where my private key resides and save the file. I am using a lot of keyboard shortcuts, so when I said save the file, I press the Command S button, which is the same thing as if I were to click here. And now that we have the configuration sorted out, we can go and download all the files from the remote SFTP server into a local environment. And to do that, we can select this command here, sync remote to local, and confirm our workspace. If we click here, we can see the logs of what's happening, and we now can see that we have a bunch of files in our local workspace. When we go here, we can see this is the file was already created. There are a couple of compilation errors. So the one thing we have to do when we set up our local environment, or when we update the packages here, is that we have to run the npm install command. Oops, that's not correct. This will pull in all the packages and the errors should then go away. I'll look into the vulnerability a little bit later. Looks like some of the packages needs to be updated. But when we go back to our script, we can now see that the errors have disappeared. We can now start building our integration. So the first thing I want to do is I want to copy the OpenAPI specification, which I have already downloaded, into Cursor, so the AI can reference what is available in ScriptRunner Connect's API. I will quickly pull a file here, and now we can start chatting with the Cursor's AI. In this case, I am going to use Composer 1, which at the time of recording is quite a fresh release. This is Cursor's own model, and it's pretty good, but above all else it's really fast, so we can save a considerable amount of time by simply using a faster model. Before I start chatting with the AI, there are many ways how you can vibe code. For example, you can give it a problem statement and ask it to solve the problem for you, in which case the AI can get rather creative. You can split your problem into smaller tasks and have the AI solve those tasks independently. Or in my case, I will build it in the same way as if I were to build it myself from scratch. I will start from bottom up. I will do it step by step, and each time I will verify if what the AI did works as intended. The first thing I would like the AI to do for me is to fetch all the logs that are considered failures from the API and print them out to the console. So let me write the prompt here. So I also want to retrieve only certain logs, not all the logs. And the logs I would like to receive are following. So these are all the possible states that the script can end up in. And the ones we are interested are either timed out, when the script couldn't finish in time, function error. So this is the main reason why scripts usually blow up, because there is an uncaught error that was thrown, which usually indicates that something went wrong. A runtime error can sometimes also happen. This is a more serious error. It usually happens because the script tried to use too much memory. And the malformed payload error is a special type of an error that can happen when with synchronous generic event listeners when you're not returning a correct payload. So I think I'm done with my first prompt here. Let's run it and see what happens. So it managed to finish, and let's see what it did for us. I can see it created a new file for us and added some existing code to our existing file here. So let's first check what's in the file that it created for us. So looks like it has managed to provide TypeScript types for our API call. Here's the function I asked it to write for me, which will fetch all the necessary logs. Looks right. It also took into account that the response is paginated, so it's iterating through all of the pages, which is nice. This is fine. I'm just going to run a quick formatting command here just to get rid of warnings, which AI usually is pretty good at getting rid of itself, but it didn't manage to do it this time. For now I can run the format document command for it, and now it looks much better. And let's check what it did for us in the main script. So it is importing the function that it wrote here. It's getting the team ID, workspace ID and environment name from environment variables also known as parameters. I asked it to get the logs for only for current day, so it's here figuring out what's the current day. Hopefully it got it right. Let's see. And then it's making the API call, and then it's attempting to print them out. So let's keep all the changes for now, and I can see already from the code that it's only printing out the number of invocations it received, but let's ask it to actually print them out so I can verify if the invocations that we are receiving are correct. So. Yeah, so it's definitely printing out some data for me here. I think it's time to give it a try. And to do that, let's go back to ScriptRunner Connect. Let's clear the logs here, and we can already see once files were saved here, which, by the way, the cursor, whenever it iterates on a file, it will automatically save it. So when you use a cursor and the AI together, you don't have to save the scripts manually, and they are automatically saved, and we can already see that the code that the AI developed for us locally is here also. But before I will run this script, I will simulate a couple of failed invocations, because I don't really have any right now for the current workspace. And to do that, I'm going to just create a new script. Let's call it generate failed invocations. And here let's log out a few things. And actually, for the last line, which is actually going to simulate the script failure, I'm going to simulate a really realistic error. So I'm going to import our Slack's managed API, and I will now attempt to make a call to Slack which is invalid, and therefore this whole thing should blow up. So I will attempt to send a message into Slack channel that I know is not there, so this one should blow up. And for a good measure, I just logged out some messages here with different log levels and different value types, so a string, a number, and a boolean value, just to give it some more examples to go by for AI later on, that is. And I will save the script and run it. So here we have an error about the Slack blowing up, and it correctly says that the channel is not found. I will now cause a slightly different error. Just gonna throw a new error here. Let's run this one again. Here we can see our kaput error here. And since JavaScript is such a wonderful language, you can throw pretty much anything. It doesn't really have to be an error. The difference is, if you throw an error, it comes with a stack trace, but you can also throw a string, for example. We have to consider this scenario also. And we have now caused 3 failed invocations in our logs. And let's see if the script, when I run it now, will manage to receive it. Oh, so we have an error here. Bad request. So let's see what went possibly wrong. So let's check the HTTP logs. So few things I am noticing. So the error message says invalid team ID format. So let's see, where is our team ID? Oh, okay, I see. I may have accidentally, when I set up the values for my environment variables, I must have accidentally included space in it. So let's fix this thing. Another thing I'm noticing here is the execution statuses. Technically this is correct way to do it, but our API currently expects them to be passed along as comma separated values. So let's ask the AI to fix this part also here. And I think otherwise it should be good to go. I'm just checking the timestamps. Anyways, let's fix and check again. So let's first fix our team ID. There's a space in it. And then let's go back to cursor and ask it to make a minor change to our script. So let's say multi-value API parameters must be comma separated. So let's see what it managed to do for us. Looks like it's indeed trying to join them together with the commas here, which let's give it a try. I accepted it. It should automatically be saved. Sometimes it can take a couple of seconds for these changes to appear in the web UI, and in the case it doesn't appear at all, then simply refresh the your workspace tab, then they will most certainly come through. But let's just double check that these changes are here, because they probably ended up here before I managed to switch over. And yes, we can see that the change is here. And let's run the script again. Okay, so we have a bit of stuff in our console. It says it actually found 4 failed invocations today. So the first one, let me just quickly check what's in it. You know, this is actually quite difficult to read. Let's just ask it to print out the raw JSON payload, which is far more simpler to read. So it indeed did what we asked. Let's accept it. But one thing I'm noticing here is trying to pretty print the JSON payload, which actually has an opposite effect in ScriptRunner Connect, because when you pass JSON object, we will pretty print it for you, and if it tries to pretty print it itself, then it actually will look rather weird. So another thing you can do in Cursor is you can ask local quick edits to be done by simply clicking on this thing, and we can say don't print it. And yes, it did remove these parts, but technically we don't even need to stringify it. Perfect. So let's keep the change. Although it would have been slightly quicker for me to do those changes manually, but since I am vibe coding, I am exclusively asking AI to do all these steps for me. And let's run the script again. Here we have all the logs, so Actually, this is something I actually try to avoid. This is the part where it is currently printed and the tabulation is not coming through correctly. So let's just double check if we are running the latest version. For some reason we are still running an older version. Let's check our SFTP logs here, if this file was pushed to remote. I think it was, but we can force another save from here. If I just try to save the file, I can see that it was synced to remote. And yes, now the change came through, so I don't know exactly why it didn't come through the last time, but that's one way to make sure that you get the latest changes. Alternatively, I could have tried to refresh the browser tab also. And let's run this again. And here we have our logs. So let me quickly review them. So we have a bunch of and so this is function error, function error, function error, and function error. So looks like we're definitely getting our failed invocations. And now we will have to, if we go to our public API, we will have to download the console logs for each invocation. So we would try to extract the error that was thrown from the function, so we can so we will know what actually happened. So we will ask the AI now to use this API call to download the console logs for us. So what I have asked is that to add a new API call into this file to download the console logs, and in our main file, once the logs have been found, to download the console logs for each of the found logs and to print out the content. So let's check what it managed to add. So here is our new function that I asked it to write for me. It looks alright, and let's see, it then added a bit of additional iteration logic to the main script, which looks fine also. So let's give it a try, and let's run the script. So this is our first error that we caused, but let me check the latest one. This is the content that is returned when you download the console logs, and we can see here that we, for example, here we have the Slack error here, and there is also a special format for how to represent the stack trace. So what I'm going to do now is I'm going to take a couple of these payloads, and I am going to put them into my local workspace because this format is currently not documented, so the AI doesn't really have any reference how these logs should be processed. So I'm just going to give it a couple of examples to go by. So I'm going to take this one, and here I'm going to just create a new file called example1.json to put it here. going to find another example now. Let's take this one. This is the one where we just throw an error with the message called kaput. And let's take this one also, which is where we just throw the hello string. So now that we have the all the examples here, the next thing I would like the AI to do for me is to try to extract the error that caused the script to blow up based on these examples. So let me write it here. So I have now asked it to, or will ask it to analyze these example files, and I am asking it to find out the reason why the script blew up. And one more thing, I also added this line here where I am asking it to make sure that it have read the ai.md file. I should have done it the first time around, but I simply forgot, and so far it has managed to be pretty good. But the ai.md file actually includes all of the knowledge that the AI should know about ScriptRunner Connect. It may have read it already, but just to be sure, I am asking it to read it explicitly. It is also a good read for anyone who simply wants to know how ScriptRunner Connect works. And let's now run this prompt. And let's see what it managed to do for us. So it added a bunch of additional TypeScript interfaces for figuring out what's the payload. It added a new function for figuring out for trying to extract the error. I'm seeing that it is trying to extract out all possible thrown errors, which technically is true, that there would be only one, but this is the part where we can be more explicit and tell it which kind of an error it should throw out. So if we go back here, the ones that we are interested in are only the ones that start with message error while invoking a default function. We are not interested in any other type of an error. So let's just give it some more explicit directions. So let's have a look now. So it's definitely added the logic I wanted. It's hard to tell exactly if it works correctly, but we can actually just try it out. And actually it did an interesting thing. It did, since I told it that it's usually the last log message that's the one that causes the script to blow up, then it inverted its looping logic, so it starts looping backwards. which is a nice optimization. Let's accept the changes and clear the log. I think these changes haven't come through just yet. Let's check this file. Oh, they have. So we can run it. So let's see what kind of errors it managed to extract for us. So here is the first one that we managed to accidentally cause, which was the 400 bad request. We can nicely see the stack trace here. Then there is the kaput error with the stack trace. Then there is Slack error about channel not found, which also looks alright, but looks like it's currently missing an invocation where there wasn't a stack trace. So we should ask the AI to fix it. And to be honest, I do not know exactly what's going wrong here, because I actually haven't really analyzed this part just yet. So one thing I'm already seeing that I don't like so much is that in some places it is using the unknown types. It's fine, but I would like it to be correctly typed, at least to the extent of the examples that I provided, because this can also be the cause that it necessarily didn't know how the structure of the these logs are, and if it did use correct types, then it could figure it out more easily. So let's ask it to fix it, and let's also ask it to try to find out why I didn't find the last log where there weren't any stack trace. So let's look at what it has managed to do. So there are definitely more types here, which is good to see. Hopefully it will help it figure out what went wrong also. And there seems to be a bit of a logic change here. But it's hard to tell if it fixed it correctly. It's just easier to try it out and run the script. Here it is. Actually, it may have been here before, I may have just simply not noticed it, but it's definitely here. So now that we know that the logic can reliably extract thrown error objects or other type of objects and reconstruct the stack trace, then now we can ask it to send that information to our Slack channel. In Slack I have set up this channel for myself, and will be sending these notifications here. So let's ask the AI to do it for us. And we also now want to send along some additional information for each of the invocation. So we want to send along how many console logs were emitted, the execution duration, execution status, HTTP logs, well, pretty much everything, to be honest. So let's just go about doing it. So I've asked it to send it to this channel to pull out most of the fields that we are interested in, and also pull the stack trace if it's present, to format it nicely, and to include the stack trace as an attachment to the actual message. So let's quickly review what it has done for us. It has created a new function to format the stack trace, to format the failure reason, and to send the Slack notification. So let's see what it's doing. So it is correctly using the managed API method for it, which is nice. Looks like it's trying to send along the attachment also, and it has pulled out some logic from here, and instead now calling this function it just created. So looks alright. Let's give it a try. Okay, so let's see what's going on here. So looks quite nice, I might add. Couple of things we can improve. So look like the failure reason kind of duplicate information, so we can ask it to remove this field. And another thing that would be really nice is if these counts were linked, because we can send the user directly from here to read the logs. So let me ask the AI to make these minor changes. I have already prepared or pulled out the links, so I'm just going to copy them in here. I don't want to have you linked. Okay, so yeah, we can see the links are here. Let's see what it managed to do with the looks like it removed the failure reason also, and I guess we can give it a try. And here it is. So we can see this is our links. So one thing I don't really like about now with these links is that these additional messages appear here, which just clutters the whole channel. Slack calls this thing unfurling, so it unfurls the URL, and we can ask the AI to not do it. Okay, looks like it understood what we asked from it. Let's give it a try again. And we have the latest here. So looks like everything is here that we would need. Here's the reason, here's the stack trace. If stack, for example, here the stack trace is not present, so only the string itself. And let's now check if these URLs also works, or if I click on here, it should take me to see the console logs. Actually, sorry, this was HTTP logs, so I now see all the HTTP logs, which looks alright, and let's see the console logs also. So yeah, that's what we initially simulated. I am quite happy with this outcome, and now the next thing to do is to ask the AI to make some changes to run it on a schedule. So what we would like to do is to find the logs since the last time when the script was executed, so we won't repeat the logs that we already may have printed out. We can use record storage to keep the track of when was the last time when the script was executed, and yeah, that's pretty much it. So I will ask this from the AI. So one additional thing I included here is that when there is no such entry in record storage, then just get the logs for the last hour, which should always be the case when you run the script the first time. Okay, so let's quickly check. It imported the record storage, that's what we wanted, and now it's going to use the record storage logic here. Looks alright. And honestly, just easier to test if it works. I'm noticing one thing here is that it stores the last execution time at the end of the script, which is correct, but in the circumstance when it doesn't get to this place, shoot the script timeout, then it will actually not be able to store the last execution time, and the next time the script runs it will try to continue from the same timestamp plus process all the logs that were added in between. In other words, it will just get stuck in this place where it might not be able to just process them in time. So I'm going to ask it to move it before it starts processing the logs, so that way even if there are too many logs for the current time period, yes, it will not be able to process them all, but the next time it actually will continue correctly, it won't get stuck on it. So and yeah, this is where I really want it to happen. And let's give it a try. So let me just put some message here so I would know it works as a marker to see if I should get all the same logs again now, because there is no timestamp in record storage, so it will get the logs for the past hour. I haven't kept the track of time, but we might still get exactly the same logs, so this will help me distinguish. Okay, so we managed to get the same logs since this was executed almost 50 minutes ago. The difference here is that this is in UTC time zone, which I actually should ask the AI to mention it, that it's in UTC time zone. And let's try it again. Now it should not emit anything because no failures have occurred. And yeah, I think it didn't. And now let's simulate another failure here. There we have it. And now when I run the script, it should only find this one that we just emitted. And here we have it. It works correctly. And the final thing I would like to do in this integration is to make sure that we can process quite a lot of logs in 15 minutes. And as I mentioned, for that I included the concurrency parameter here, which controls how many concurrent jobs can run in parallel. And to do that, I am going to pull in a third-party package that will help me to do so. So here is a package that lets you run promise.all commands with limited concurrency. Because if you run promise.all as out-of-the-box implementation, it will run them all concurrently. So if you have 1000 logs that needs to be processed, those 1000 will run concurrently. And there are rate limits both in ScriptRunner Connect side and in Slack side, so we should make sure that we are not going to trip over on those rate limits, so this will help us to do so. So I will now include it in my workspace, and in here I have to now to get this to appear here, I have to now sync the remote changes here again by selecting this command, confirm our workspace, and here we can see that the package that we added in our online UI is now here, and that this is the way you should do it. You shouldn't be putting new packages here, except the packages that you may only use locally, that they can go into the dev dependencies section directly. But anything that you would like to use in the actual workspace, you have to do it first in the web UI. And the reason for that is if we did add it here, then this change wouldn't propagate over to the web version. So the script would run fine locally, but when you try to run it in ScriptRunner Connect runtime, the package would be missing. But now that we have the package here, let's also run the npm. Sorry, I already have the terminal open here. Run the npm install command, so it would pull in the content for this package, and we can now use it. So I'm going to ask now an AI to parallelize this work using this package. Let's see how it manages to sort it out. And let's see what it did for us. So first of all, it has pulled in the necessary function from this package. It's extracting our concurrency from environment variables, and it is seems to be doing it correctly. So let's give it a try again. Let me emit a couple of failed logs. I just do it twice, so we should be getting the logs for, should be getting 2 logs for when I run the script. And here we have, these are the logs I just generated. So the addition of this promise throttle all package seems to be working very nicely. And talking about rate limits, then one thing that I also would like to do in my workspace is to make sure that when should you get rate limited from our side, that this will be retried. This lag is actually fine because if I find this lag here, this is using our managed API, and our managed API comes with built-in retry logic when you're getting throttled. But in case of when we make direct fetch API calls, then this logic by default does not get retried. So I will ask the AI to include a logic here, so when we make these fetch calls, that when we get 429 back, which means that we have exceeded our rate limits, then retry this operation 1 second afterwards. So let's have a quick look. So it included function to sleep for a number of milliseconds. It included another function to retry on 429. And let's see what else did it do. It's now pushing these API calls through this retry function. And yeah, it looks like correct. Let's accept the changes. And let's just try it again. So I will generate another invocation and run the script. And here it is. So the change it made still works. And now the logic should be more resilient. And that's pretty much what we wanted to achieve. We now have logic that will get us the latest failed script invocations. The only thing left to do here is instead of me triggering it whenever I want to test it, is I will just enable this event listener here, and now it will start doing it for me automatically every 15 minutes. I will go over the code and potentially ask the AI to clean up in a few places, but otherwise the logic works nicely, and this template will also be made available for all of you to use if you want to get your script failures sent to your Slack channel. And thank you for watching.